Please, Dr. P.R. Zawar, sir.
Thank you, Professor Patil, sir. I feel glad to introduce our today's speaker. Thank you, Professor Patil, sir. I feel glad to introduce our today's speaker, Dr. Ahmed Sohezi Matsu. Dr. Ahmed is a very promising agriculture engineering personality who is having 10 years of rich experience and working in University Putra, Malaysia, as well as many other universities. He is meritorious throughout his academic and got various fellowships and awards like Outstanding Student Graduate Award by International Society of Precision Agriculture, Federal Scholarship, and Best Paper Awards at various international and international conferences. He is an alumni of prestigious University of Nebraska, USA, and McGill University, Canada, bearing key research areas, soil sensors, climate change. He is actively involved in American Society of Agricultural and Biological Engineers and Malaysian Society of Agriculture Engineers. He has series of publications including 10 high quality research articles, 34 conference proceedings, and 3 books. Dr. Ahmed currently handling 11 research projects, a lead researcher and co-researcher granted from various apex bodies of country. With this brief introduction, I once again welcome you virtually on behalf of NAHEP project, that is Center of Excellence on Digital Farming Solutions for enhancing productivity by robots, drones, and AGVs. Now I request Dr. Ahmed Sohezi Matsu to deliver his presentation, please. Thank you.
All right. Good evening, everybody. I hope everybody could stay alert during this time because we are pretty much the same situation in Malaysia as well as in India. We're still under MCO, so everybody should aware of that. And plus, I should thanks to Dr. Zanwar, Dr. Patel, and also Dr. Gopal for special invitation for this session. So for your information, this is quite ad hoc for me. However, I'll try my best as possible to share the most important topics today, which is on the drone technology for the crop protection. With this regard, my focus for the presentation will be on the spraying. We have been listening throughout the session, and especially this morning with Dr. Knott. I think he covered quite well in terms of the broad spectrum, in terms of the sensors application, and also the tools that can be promising for the agriculture utilization. However, I think it's not fair to repeat the same thing, but then I have some time to polish up my presentation, and then I think this is a critical, one of the most critical topics. Dr. Knott did mention at the end of the session that there is a concern on the spraying effectiveness. So today I'm going to share about it, and then we did a lot on that also, because situation in farming in Malaysia and India might be similar, because each farmer might own the farm individually will be less than 1 hectare as minimum. Okay. Before I proceed for further, let's get some overview of the. Sorry. Okay.
Please make a slideshow, sir. Please make slideshow. Your screen is visible, but two
Okay.
screens we are seeing.
Two screen. Okay. Sorry. Thank you for that.
Yeah, it's fine.
It's fine now.
Yeah,
I
fine, sir,
think it will
fine.
be better. Swazi, can you make the F5 or make the presentation show? Will it be full screen?
Yes,
Yeah, it
I
is.
did.
Oh,
I did
yeah.
already. Like
Can
this
you
one.
make it full screen?
Is it okay? Better now or not? Still the same.
Only single slide view. There is a two slides immediate
Yeah.
predecessing. Single
How about
slide.
like this? How
Okay.
about better? Okay. So
Yeah, yeah.
I think
Yeah.
something wrong with
Downside.
my, yeah, I think something wrong with my computer setting. So it might not be actually have enough time to sort it out at this time. Okay, let's
It's
proceed
okay.
on this
It's okay.
one. Yeah. Okay. So this is my outline. So we'll touch a little bit on what is smart farming for digital agriculture, and then mostly we'll cover on digital agriculture, what it's all about. And then after that, we'll cover on the drone technology for the crop protection, some case studies, some of the research done, and so on. Okay. So have you seen in many publications, people are talking about agriculture 4.0, and then that's make you trigger the interest of utilization of very advanced technology. But bear in mind that with advanced technology, that will require integration of multi-level operations, connect suppliers and also customers, electronic and digital form. So of course, in term of the stage, you would have stage 1.0, 2.0, and 3.0. This is where we are mostly situated, where Malaysia and also India, you can see most of the farmers still practicing the farming practices at this level. And then towards the end is actually 5.0, which is toward artificial intelligence. We are not far from that actually. We are already halfway done through that stage. But in agriculture, most of the data basically is sensitive for economics and also for the farmers, so they were not released to the public domains. But I believe every government have their own data set, and then that's toward the for better management. This is until that's actually we can form in terms of the better management using artificial intelligence. So speaking of again agriculture 4.0, so the question is are we there yet? So yes and no. Actually, the answers depend where you are looking at. For example, I'm in Malaysia. We are already halfway done through the agriculture system. Uh, the main driven factors is because of the labors, and also the cost of production is keep increasing. So we have to utilize the current technology and also a new method of producing food. So this is pretty much the way of thought, and also the way forward in order for us to get it advancement in terms of the agriculture practices. So this is some of the scenario that I took from this reference. Basically, you compare with traditional enablers versus target-oriented technologies. With this, you will get pretty much a goal focus for the activities and also problem solving for the agriculture solution. Okay, so here I would like to talk about what is the challenges and current situation in Malaysia. The rice is one of the staple food in Malaysia. On average, we produce across across Malaysia is about 3 metric ton per hectare. Is considered relatively low. Um, large, there is a large variability from one location to another, because there is an efficiency of the production. They might have different operation in terms of the application of machinery. Some other area will not get the proper assistance from machinery. Some others yes, and also different type of fertilizer use and so on. And then in terms of the yield, the highest record that we got, actually, we could achieve up to 13 metric ton per hectare. But this is very rare and then depending on the season. The self-sufficiency level, which is reflects to our ability to produce our own rice in Malaysia, is at 70%. Maybe in India is close to 100. And then the remaining 30% we have to import from Thailand, Vietnam, and also Pakistan. Okay. And then if you take a look across the field cultivation for the paddy or rice, you call it, so it's quite intensive actually. So across this period of cultivation, it will take about 3 months or more or less 120 days, depending on the variety. Some of the variety less than 100 days, and so on. Yeah. Okay. So why actually we want to introduce the drone for paddy? So if you take a look here, we did some benchmarking with the mechanization index. Yeah. So we use boom sprayer, whatever machinery, conventional tillage machinery, for example, like rotary tillage, disc plow, etc. So we did a ranking and then compare as well the field capacity. And what we found, actually, the field capacity for tillage is about 1 hectare per hour, and the lowest here is the seeding. And then the mechanization index shows that how much actually the machinery being utilized for the rice cultivation. The value that close to 1 is the best. So as for now, for example, like harvesting. So when we got the 0.99 index, meaning that we fully mechanize, okay, but not for seeding, fertilizing, and also spraying. So this is the area that we want to focus. We want to solve. We want to have the farmers to increase the mechanization index and also to reduce the fatigue and stress during cultivation exercises. All right, so this is the typical seeding, spraying, and also fertilizing operation. So you might have manual by hand in your country, and also in Malaysia, also people still actually do it by hand for seeding. And then with this actually a semi-automatic using knapsack blower, using a motorized system. And you can have also the same units, the same system configuration for the spraying as well as fertilizing the area. Okay. All right. So what's the problem of the current practice? So what we have here, basically, we have very relatively low work quality. For example, like if you have the operator, they have to enter the field. They have to walk in the field. Sometimes if you have experience in the field, wet paddy field, you have to walk in the field up to your knees. So it's kind of like quite tedious and tired. So there is also a tendency for the workers damage the crop because during early stage they have to walk in the field to apply the spraying the chemical and also the fertilizer. And then relatively low in terms of the ground speed. So only 25% farmers follow the SOP for walking the speed, working in the field. So the rest basically skip the one of the parts and basically don't follow the standard operating procedure. And then one of the most critical regarding the spraying, basically most of the farmers actually, some of them actually use overdose chemical application. So this is actually quite dangerous in terms of the food safety. In terms of the spraying path, the study that we did, only 30% farmers mark the following path for the field plot, and only 20% follow the standard SOP for 10 paths per plot. So the plot that we talking about here in Malaysia is about 1.2 hectare area, more or less 3 acre each farmers, each plot. And then in terms of the timing operation, 60% farmers follow the standard operation on for the time of spraying. So this is a common problem that is the reason why we want to commit with a new technology, new approach. All right. So why drone that we want to introduce? We are not the first entities. Basically, there is one we call it kind of like regional authorities. We work together with University Putra Malaysia, UPM, our university, to conduct a research regarding drone. So right now, the situation will be, I think until now, if you look at in the world stage, there is no technical specification standard for the drone. Although there is US side and Canada side, there is some regulation and so on. But in terms of design and so on, related for special for agriculture, there is almost no guideline for that. And then no spraying chemicals, especially formulated for drones. So this is actually quite important, because this is where the effectiveness of the chemical will be quantified. And then no SOP, standard of procedure, to set up and to operate drone for chemical spraying for rice. So this is why we want to propose this approach in order for us to cover these aspects. Okay. All right. So in Malaysia, we actually hire B40. B40 is below 40% of the income capital. So more or less about less than $1,000 USD per month income. So among farmers. So with this technology, we actually evolve with young generation of the farmers to work in efficiently in periphery. So with this nature of the work, which basically we want to reduce the fatigues and also lesser 3D nature of work, difficult, dangerous, and dirty. So right now we have about more or less about 500 pilots in the farm. So they are working actively across different sectors of crop cultivation. And then prospect of the drone. Of course, when you are talking about the drone is autonomous on high precision tracking. And then it has excellent maneuverability, and then able to do the vertical takeoff, horizontal, and so on, able to incorporate crop health scanner, camera, sensors, vision, and etc. And then, of course, towards that, you can have the variable rate applicator. And then in terms of the efficiency of the farm operation, so you will have very low time loss. Yeah. And then, of course, some of the area, basically, you have a very sensitive area to the crop damage and also pest and disease. This is where the drone can actually help you to reduce such a problem. All right. If I remember well, this morning, Dr. Not, professor from Washington State, also mentioned about what are the main factors that drive the efficiency of the spraying. So as listed down here, it's not only from the drone, it's actually there are other 5 parameters that we need to consider. First is the weather, the drone itself, the unit itself, the machinery itself. Third is the chemical that we use. Fourth is the spray tool, the nozzle type, arrangement, size, etc., the pressure. And of course, the last one is the environments or the crops that receive the chemical. So all these factors have to be integrated. But among these 5, there are a few factors that we can easily manipulate it or control, which is drone chemical spray, spray chemical, sorry, but and also the tools, the configuration, and so on, so that we can play around. Okay. All right. For the research that we did, we tried to understand and then try to establish a benchmark in order for us to do some understanding and also the mapping of the spectrum of different drone design. Yeah, what we can do basically, we want to develop a standard test protocol. So to do this, we have to do in lab test. So we almost 80%, I think 70%, yeah, for the indoor testing facilities. That will be for the commercial and also for research and the development purposes. So this is this is also welcome for any party from India if you want to collaborate with us for this for this research. Yeah. Okay. So uh, so this is the study for benchmarking the study for research drone for agriculture, in particular for rice, and also we are going to do some of the chemical spraying for chemical properties itself in the wetland rice cultivation. Okay, so if you take a look across the I think this is one of the popular drone that available in the market. For example, like DJI iGrass, DJI iGrass 1P, and then across other brand as well. The most important factors that we are interested on, basically the lower one, which is I put in the box, the field capacity. In the engineering aspect, this is very critical. Across those products, across those brand, and then also the model, they have very huge variation in terms of the actual uh, field capacity. Of course, this is estimated, but during our test, we found that they have a different ability to produce different capacity. So the question is, which one is the most accurate when they claim on such website? If you take a look on the website, sometimes they claim what's the capacity. It sometimes is unlogical. Sometimes they claim up to 20 hectare per hour and so on, which is doesn't make sense. Yeah. And then what factors that we need to consider? So those are the criteria that will be evaluated in the our exercises, our research program. Okay, so for the chemical, so what we found basically some of the chemical that we use across agriculture product for pesticide in particular. So there is SD stand for surface tension. So there are not much surface tension variation, viscosity and density. So we compare the products basically. So when we compare those, basically the variation is not much. So there is a very slim for us to get to narrow down the range that's suitable for the drone, but it can be done. Okay. All right. To do that, we also did some benchmarking in terms of the spraying angle, spray width, and also droplet distribution. So this is inlet testing. So we simply put the water sensitive paper and then check the droplet size, and then of course across the standard product, we can see that it has very unique patterns. In particular, if you put a benchmark here as a water, so you can see the droplet is quite uniform. But towards the end, if you have a special modification for the liquid, so it's entirely produce different game for the uniformity of the drone spraying. So this is the setup that we did. Actually, this photo took, I think we took an early this year. It's located in UPM. So I think we are already like 70% done with the acquisition system and so on. So we expect at the end of this year, we'll be ready for fully test for commercial drone and also for new drone system. All right, so this is more or less the system that we propose. In order to monitor the spraying characteristics, yeah, so these are the parameters that we need to monitor. For example, the spray width, how large the acreage, how large the area that can be covered, and then spray profile in terms of the droplet spectrum, number of droplets, concentration of droplet per area, spray drift deposition, and downward pressure profile. So all these parameters will be captured in this test rate. Yeah. Okay, so we did also some uniformity tests on the most popular drone, DJI Agras 1S. So basically the configuration right now as the current model, basically Agras 1, DJI Agras 1P. So similar configuration for nozzle and also for the blades, for the motor numbers. So this is some of the example of the flight path that we took on the system. And also this is the patterns of the operation on the recorded flight data. So we can see the spraying height and also the mechanism during hovering and also transition on the described path. All right. So we did also some deposition lab. So as compared to the spray blower, mist blower, so versus drone. So this top graph and then the green color is from the drone at different height, 1.5, 2.5, and 2.0. Yeah, so that bottom is 2.0 to compare. So if you see from here on deposited rate, so of course, Miss Blower is already pre-anticipated. We produce the most uniform. You might have a question like why actually Miss Blower have the most uniform as compared to the drone, because the nature of the application using Miss Blower, because it's normally is horizontal direction as compared to vertical from the drone. So from here you can see that the variation from the drone is actually quite large. However, it's like a bell curve. Well, it's like yeah, it's bell curve. However, spray deposition at 1.5 is the lowest. Yeah. Okay. And then we also monitor the drift. Yeah, how far the drift could travel. Yeah. In this case, we just use the water. Yeah. And then we compare at two different level, top, middle, and also bottom, and also at three different height during drone spraying, drone versus sprayer. So we can see that the drift actually increase with the increase of the height of the drone, as well as increase towards the from the source of the sprayer. So in this case, the drone could travel up to 25 meters from the source. So bear in mind that imagine if you have the spraying chemical, pesticide or fungicide, which is dangerous for human and public. So this is where the safety aspect that could actually play around with this. So same finding that actually we monitor for mist blower. Same effect that could travel up to 25 meters. Actually, according to the standard, we should test actually further away. But at this moment, we try to understand first how far it should go. So according to the American standard of biological engineers, we should try up to 200 meters. So that's we don't have that capacity yet because our lab basically the longest that we had basically up to 25 meters only. So in the lab we can control the wind, we can control the environment and so on. So it's difficult to have those range. All right, the position for the field. So this is the field test, actual field test. So we can see that from 2 meters height is actually similar deposition with the mist blower. So which is actually reasonable to suggest that maybe 2 meters high is the maximum that the drone could actually fly in order to get the most uniform spraying deposition. However, depend on the drone spraying configuration. So that's actually we are looking for next research aspect. Okay, and then the drift, of course, we are looking for something that more beyond this effect. So in the field, we did test in the lab versus field. The previous one was in the field. Previous one was in the lab, and now is in the field. So we can see that still actually it could travel up to 20 meters farthest from the source, yeah, at two different levels. All right. So the general recommendation that we propose basically, in order for you to have the optimum range of the spraying distribution, So we recommend for the spraying in rice production is only between 1.5 to 2 meters from the canopy. However, this recommendation might not be whole if you have um, some of the crop basically uh, could stand with the downward pressure from the blades. For example, like pineapple and so on, it's not sensitive. So some of the crop, basically like chili and other vegetable like leafy green, that very sensitive to the pulse, lodging index, for example, or lodging due to downwash. So you might have to choose a proper height. So here we are talking about rice, yeah. So spray drift could travel up to 25-meter radius. So this is where you can actually take precaution to stay away from the source, or simply the operator should put the PPE, personal protective equipments, in order to protect from the dangerous chemicals. Okay, and then in this case, we also recommend to do the spraying only in the morning before 11 a.m. and also in the evening after 4 p.m. So that will be the best spraying operation time, due to most of the atmospheric condition will be mostly stable. So and also it may vary from one side to another, and also season. So that have to be uh, bear in mind. Yeah. Okay. So in terms of the expected outcome, so we would like to have basically a standard of operation for the drone, uh, uh, and also to improve the drone design in order to meet the requirement for important design and also operational criteria. Secondly is to have the rice cultivation industry in Malaysia to be uh, propelled towards the advanced technology utilization. So this is where we can actually enhance the resources, because especially right now, for example, during COVID-19, we have limited or shortage of labor. So this is where the system, the technology can come in and play with the spraying system. Okay, so in the broad view, why we are doing this? So we have the uh, bigger agenda in terms of the not only spraying basically. So what we want to do basically for the advancement of area surveillance and also artificial intelligence for monitoring and enhancing rice management system for Malaysia. So in this, the drone is just one of the topics. So in order to propel towards the decision support system, so all these characteristics have to support each other. So in other words, basically, we have to consider system dynamic parameters in order for us to have a smart management system utilization in digital agriculture 4.0. So with that, thank you.
Thank you, sir, for showing the insights of drone technology. We will take some questions and we'll have discussion with participants. Participants, if you have doubt or you need some clarification, you can raise your hand. I think Dr. Sujata Pawar has raised her hand. Please unmute Dr. Sujata Pawar. Hello. I think Dr. Anand Gore. Dr. Gore, sir.
Dr. Suhazi, we were there for some time.
Yes, I'm here.
Yeah, we were meet in university campus and there were a lot of discussion. However, we like to continue the mutual exchange collaboration during this discussion. Professor Shukur was there, and he is a dean now, I think, I suppose.
Correct.
And
Yeah.
yeah,
He's one of the member for this project as well. So
yeah, he is one of the member, and we feel proud that we will be continuing this discussion with some mutual
excellent.
research exchange. Uh, Let us go ahead with the question and answer session. I think people are very eager to know, and I'm very much thankful that on the 11th hour you have accepted my invitation.
Okay. So any questions from the floor from the participant?
So, Dr. Gore, sir, you can ask your
Yes,
question.
I'm audible, Dr. Patil, sir.
Yeah.
Sir, it is very informative lecture. Thank you very much for NAHEP team and all organizers. Sir, my question is that we are growing aerobic rice, particularly in our Marathwada region. And in case of aerobic rice, we want. So in that case, how we can utilize the drone frequency and how we can get the moisture regimes, particularly in soil and in also in case of canopy, particularly in case of rice. One. Second is that there is deficiency of nitrogen. We generally occur in case of aerobic rice. So how best we can go for scheduling the nitrogen spray through the
Okay. So may I proceed with the answers?
Yeah,
Yeah.
please
All right.
proceed.
I think the first question regarding aerobic rice on the water regime. So basically, you can actually, yes, there is a technology that you can actually use to monitor the water regime uh, in the field. However, that depend on the growth stage of the rice field. Most of the towards the I think uh, after 60 or 50 towards 50 and above day after transplanting, you might have difficulties to monitor the water regime using drone. However, there is a method that you can actually utilize the water pressure sensors, or you can actually have the physical sensors that could log in a temporal time for you to monitor the water level. And then this can actually help you to quantify the water regime. I hope I can answer that questions. Okay, question number two regarding aerobic rice again on regarding the nitrogen deficiencies. I think most of the farmers actually looking for a cheap fertilizer, for example, organic and also urea fertilizer, right? And then speaking of urea, chemical fertilizer, this is the least efficient fertilizer that tends to be leached out from the field. So what you can do basically, you can choose other type of fertilizer, for example, like foliar fertilizer using drone. So which is a fast acting fertilizer can be instantly absorbed by the plants. Okay,
Yes, next question.
I hope
Next
I answer your
question,
questions.
Dr. Bhushan Patil. Please unmute yourself.
Yeah. Sir, am I audible, sir?
Yeah. Please.
Yeah.
Please ask.
So, first of all, I will express my gratitude towards the professor for such a nice and informative session. Sir, my question was regarding, sir, during spraying operation, if our in India or maybe in we have some fragmented land pieces in our region. So, and there is a problem that we have undulating fields. So, does this aerial vehicle is smart enough uh, to attain the height adjustment on the real go while spraying operation?
Yes, thank you, Mr. Patil, for the questions. Yes, there is recent technology for the drone, for example, DJI. Actually, DJI open for the system. You can sell the parts of the sensors. They call it radar system. The maximum height that can be detected using radar is only 3.5 meters. So above that, they will be using barometer sensors. So what this sensor does, basically, they follow the train, undulating train. So like say you have a undulating train, and then sometimes you have up here and then come down. So they will exactly follow the train. Even not only the train, you can follow the height of the plants. So it will respond back to the height from the sensor that you set in the system. So in order to do that, basically you need to have the sort of like automatic flying mechanism. So of course you cannot do that in using a manual approach.
Okay, sir, and I have another question regarding regarding the agitation system. Does we provide any agitation system for these sprayers, or maybe its capacity is so smaller, so it doesn't require any agitation system?
Sorry, can you repeat again the question, Patin?
Yeah, sir, my question was regarding the agitation system to maintain the uniform solution. So does we provide any agitation system, or we neglect it due to its smaller capacity?
Yeah, normally in actual field operation, the chemical is already pre-prepared in the tank, in the separate tank. So when the drone need to be refilled, they just pour in the drone tank. So the drone capacity in Malaysia, because we have regulation to even the international regulation also have through FIA and so on. So the maximum takeoff weight must be less than 20 kilogram. So meaning that more or less the liquid that you could actually bring is more or less about 10 to 15 liters only. So
I have one correction. Is it 20 kilogram or 200 gram?
20 kilogram.
Is it?
Maximum takeoff weight by regulation.
Okay. But
I don't know about
here in
India.
India,
Maybe I don't know about India. Maybe you have already
200
have
gram. 200 gram.
no way 200 gram.
Yeah, the 200 gram weightlifting capacity of that is only allowed according to DGCA rule, Government of Defense Ministry Office. They have restricted, not yet started regulatory services for only agriculture field. I think we are just bound to be remain in the research and experimentation. So we will soon receive that permission. Up
Okay,
to two, up
yeah,
to 20 kg, up to 20 kg.
okay. That's good. That's good to know. 200 gram you can't do much. Basically, just a toy
Just
that your
lifting of
kids
camera,
play.
that's all.
Of course.
Exactly. So you can't do much for agriculture. For spraying, you need to have at least 15 kilogram because the self weight without the water is more or less between 10 to 15 kilogram
Yeah.
weight. And then when you start pouring the liquid and then into the drone, so basically it could go up to beyond 20 as permitted by regulation. Sometimes farmers go, but normally we advise not to go because anything happens, so they will get sued and so on. So it will be risky. So answering Mr. Patel questions, yes, there is no specific mechanism to agitate the chemical because the chemical technology is already take into consideration how long it will actually suspend in the water. But normally it will not be happen because they actually is a commercial product. Okay.
Thank you, sir.
Thank you.
Now we have with us Dr. Kenya of your university also, University Putra, Malaysia. Now I request Dr. Kamlesh Golani to interact with Dr. Ahmed, sir.
Hi Kamlesh, I know you. Okay, I cannot listen. So
Just
Good
wait
evening,
a
sir.
minute.
yeah, good evening. How are you?
Up awake.
Yeah, okay.
So it actually, first of all, I thanks to Dattatreya that who informed me immediately that you are coming for taking the lecture, and I'm very surprised because we are interacting almost after 1 year, because you was part of my presentation, and afterwards we have a not so long contact, so it's a really very nice to meet you, sir. In
Okay,
my side, I do not have any question because I have taken Dr. Helmi's course that
I
time.
see.
He yeah, in your faculty, so he taught, he bring me, the playground, and he demonstrated the all the drones, but I want to ask only one thing, sir. I think this sensor is good for fitting to the drone,
Which
like it's a,
sensor?
yeah,
What?
like is the hyperspectral sensor or multispectral, I mean.
Well, depend on the budget basically, and what's the purpose of the camera. Even with a simple camera, RGB, red, blue, green, like your smartphone camera, can do a lot of things as well. For example, you want to monitor the leakage of irrigation. For example, you want to do the thermal related with the irrigation system and so on. Or you could also have the correlation with the NDVI versus RGB or saturations for the crops. So of course uh, this is where you would expect the accuracy will be less than 80%, but still actually applicable. But speaking of the sensors, if you want to go for hyperspectra, um, the cost is quite substantial. It's like we try to acquire. Well, UPM going to have one. So the good brand I think is about like more than 50,000 USD per unit, excluding the drone system. So that the cost is quite substantial. And then to quantify the real application to the farmers is a bit challenging. But for research wise, for research perspective, we got no limit. So
Sir, but as far as I know that using RGB we cannot calculate NDVI, so at least we need extra, one IR band. So we have to think for any sensor
correct,
in which having the red or IR. So it must be, less price, so we can fit on the drone specifically for plant protection or drought studies. So if you
correct.
have
But
any
you
such kind of the, less price sensor, so please inform me, sir.
Um, that's actually what I had in mind before. Could we actually produce a cheaper method or faster method just using a smartphone, basically RGB? So what you can do basically run the correlations, find the surrogate approach between saturation index instead of RGB. Saturation index is on RGB but different index. Uh, versus NDVI. So basically, that's one way to skip using multispectral because you can actually save the cost. Otherwise, you could have also another index. I forgot there is one publication from ACBE before, uh, also based on RGB, because farmers normally will not get enough money to have access on multispectral. So this is something that I believe uh, colleagues from India excellent in terms of the brainstorming and come up with a good and practical approach, cheaper way to help farmers.
Right, sir. Thank you, sir. Nice to talking with you.
Thank you, Kamesh.
Thank you, sir.
Keep
Thank
in
you,
touch,
Dr.
Kamesh.
Kamlesh.
Yes, sure.
Yeah, yeah. If there is any question from the participants, you can raise hand. We will take one or two questions more, and then we will sum up this session.
Yeah,
If it is there, okay. Yeah,
someone emailed me, but I will not be able to open right now. Maybe later on.
yeah, yeah, yeah. Sir, I have one my question here.
Yes.
How we can increase the battery performance in drone?
How? What?
How we can increase the battery performance?
Oh,
Battery
the
Battery.
performance.
battery performance, the power.
Yeah, 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 yeah.
There is a few option. You can go for the IC engine, internal combustion engine. without using battery. This is where the current well, you can moving forwards, because relying on the battery, you have very limited power. One pack of battery, two set, yeah, sorry, one set, which is two batteries, could only supply the drone of 8 rotors up to maximum, with the weights, with a load of 20 kilogram, up to 15 minutes. Yeah, 50 minutes only. But
Yes.
we are limited, if you are even you introduce with the IC engine like commercial airplane and so on, but we are limited uh, by the rule and regulation. Yeah,
What is
so
this ultra? I think this is ultra storage. Nowadays, the batteries are coming up in the market, and still it have some extra capacity. These
I'm
things are coming up with new technology. And secondly, solar tower systems with solar, you can say silicon cells for the on the way when it is taking off, and the flight is when take off, that time the sunlight is there, and by the time that get charged parallelly. So thinking of such as battery which can be solar cum photovoltaic system can be one of the new challenge for this drone UAV technology.
Yes, Dr. Gopal, it's good idea to have a solar
This is my
power.
idea actually.
Yeah,
This is my idea.
yeah.
We are proceeding for that.
Yes.
Yeah.
However, the challenge is the rate of the charging to the battery.
Yeah.
So that's a challenge right now. If you have very fast charging through the solar system, then you can fit in the solar to the drone system. Right now, we don't see yet that kind of technology, unless maybe Tesla want to do something like similar for agriculture. So that's different story. Regarding the battery technology, yes, I'm aware of that, but I'm still skeptical in terms of the performance. Um, because imagine you are in the field, you want to do the spraying right away. You don't want to waste your time waiting for the battery to be charged, as for the current situation. So most of the farmers prefer to have the IC engine, two-stroke engine, which is normally people use for common for hobby, for flying hobby.
Yeah, helicopters type systems where the IC engines can be
Correct,
inserted. Yeah, yeah.
correct, correct, sir.
What are the current researches you are doing in UPM now?
What are the what?
Your current research projects,
Oh,
your
okay.
current
So
research project.
currently we did also on agrovoltaics, other than drones, agrovoltaics and also precision irrigation for durian. Durian trees is a big
Yeah,
market for
yeah,
China.
yeah.
So we
IoT tool,
are.
IoT tools you are using now, might be.
I think in India also you have that kind
Yeah, yeah.
of
We have that.
durian,
We have
different
that.
varieties. Yeah, so it's a high demand in Malaysia, mainly in Southeast Asia. So there is a high demand for that kind of fruits. It's seasonal fruits, but it's very unique taste and so on. And then we are looking for specific condition for the water regime in order for to trigger the flowerings and also for the growth. And other than that, rather than agrovoltaics and precision agriculture, we also looking at the machinery mechanization for the smallholders in oil palm. This is where more or less downscale towards the real application. I think in India you have a John Deere, you have a quite big numbers of big company that actually have the setup for the machinery. But in Malaysia, we normally have relatively quite low margin in terms of the farmers' productivity. So farmers tend to use a small scale oil pump, small scale machinery in order to for them to lower the cost and also increase the profit margin.
We have a tomorrow speaker, Professor Raima Labard from Algeria. Raima, are you there? Raima Labad, are you there? Okay, professor from Algeria, Dr. Raima Labad will be tomorrow delivering us this technical section. She is trying for the herbicide applications through drones, or maybe have a robotic application, but the drone is the main objective for that in
Yes.
Algeria. Yeah.
Interesting. So, see,
I,
everybody actually interested on the drone. So we should come up with maybe collaboration with the drone.
And one more surprise I would like to add, Dr. Suhaisi, that we are also planning for a hybrid kind of UAV. Why? Because the UAV is turning around in the flying mode, and there we require, suppose, a robotic arm manipulator. So we can add the manipulator in drone. I mean, this talking about UAV. So UAV in club with one of the articulated arm with the end effector, and that is reaching in any of the multiple axis of motion direction while performing operation. We'll have a multi-physics and the multi-dynamics state of art, and that is we will be definitely thinking on this part. We'll work together. Professor Rafa Linker, he's from Israel, also yesterday joined with us, and Professor Love Khoth from USA, he's also joined with us, and you too, because we had a meeting with a Malaysian team in the last year at Pune meeting, and that time we sorted out the discussion point. Professor Siva Balasundaram, he had been to this place. Yeah.
Okay.
Yeah. So we have already initiated MOU with your university, and I'm very happy that all of our participants have really enjoyed. Thank you. Thank you.
Thank you, Dr. Gopal.
Thank you, Gopal sir. Some other time we will see you physically in our campus, Dr. Ahmed sir.
Sure. Thank you, Dr. Gopal.
Now I request Dr. P.R. Zawar sir to conclude this session.
Thank you. Thank you, Dr. Suhaiji, for accepting our invitation at 11th hour and delivering your nice nutshell talk to our participants, and participants enjoy it. Once again, thank you. Thank you. And
Thank you very much.
on behalf of this Center of Excellence, DFSRDA, and our university, once again, I thanks to all of you. Thank you.
Thank you.
Thank you.
Thank you.